Hi everybody, we're finally ready for our area formula. Based on our work approximating areas using rectangles and seeing how as the number of rectangles increases, the approximation gets better and better, we're going to define that area to be the limit as n goes to infinity of those Riemann sums. Remember, R sub n means the area you get if you use n rectangles. Now, there's a theorem that tells us how to evaluate this limit. That theorem says that the limit works out to be the definite integral from a to b, in other words, between our two x values of the function. And maybe I should make a sketch here to remind us what we're talking about. If I've got some function, f of x, and I want to know the area underneath that function and above the x-axis, between two x coordinates, that's what I'm calling the a and b, it turns out that area is the definite integral of the function from a to b. So putting all that stuff together, here's our area calculation method, our formula. The area A is the definite integral from a to b of f of x dx, where I'm talking about this area right there. Let's see an example. In fact, let's calculate that area that we were estimating before. Let's calculate the area below the graph of the curve 1/5 x squared minus 2x plus 6, above the x-axis and between x equals 1 and 7. So I'm going to do definite integral from 1 to 7. Don't forget to label what you're calculating. We're calculating an area, so write a equals. The function is 1/5 x squared minus 2x plus 6, and we have our dx. And all we have to do to get the area is just evaluate that definite integral. So let's see, I'm going to have 1/5 times 1/3 x cubed minus x squared plus 6x, going from 1 to 7. So that is 1/15 times 7 cubed minus 7 squared plus 6 times 7 minus what you get plugging in the 1. So minus 1/15 times 1 cubed minus 1 squared plus 6 times 1. So I'm going to have 343 over 15 minus 49 plus 42 minus 1/15 plus 5 So 343 over 15 minus, let's see, minus 49 plus 42 is going to be negative 7. And then distributing the minus sign into the parentheses, I have negative 1/15 minus 5. I'm going to go ahead and combine my two fractions just to make my life easier when I turn to the calculator. That gives me 342 over 15, and then minus 7 minus 5 is minus 12. Let's get a decimal for this. And I'm getting 10.8. That's the exact area. Let's compare that to the approximations we got before. Our first approximation, which was a gross overestimate, was 25.2. Then doing a little better, we got 16.2. Then with 3 rectangles, we got 14. You can see this is also still an overestimate because there's so much stuff sticking up above the curve. Now this last rectangle was a little bit of an underestimate, but still, in total, we've got more stuff above the curve than below. So I can see that 14 is an overestimate. And what we just discovered is that if we took infinitely many rectangles, in other words, the limit as the number of rectangles goes to infinity, we would get 10.8. And that is, again, let me emphasize, this is the exact area. It's no longer an approximation.